quick. All right. I lost it. One sec. The page just closed on me.
Okay.
All right. You ready?
Uh-huh.
Okay. So
Oops, hold
we're
on.
doing the things where
Hold on a
you
second.
change like you find like the what is it? So on like a unit circle, you know how there's like the pi over 6 and
Uh-huh.
everything. We're doing like so if you do like sine of negative pi over 6, we're doing that, converting that to the, what is it called? The coordinates.
Okay.
So our first one is,
I think I understand what you're saying. If you want to read a specific problem, we'll be able to do it.
okay.
Hold on 1 minute. Let me get my program up here again. It was acting up on me a little bit there. Oh, man. This thing's going wacko on me. Now it's open twice. All right, let's see if I can write. All right, go ahead.
All right, so the first one is find the coordinates for cosecant negative pi over 6.
All right. You're just barely getting into trig?
That's what our teacher said.
Okay. How familiar are you with radian angles like this is?
Okay.
Are you still more comfortable converting that to degrees?
We can keep it in radians.
Okay. So what angle is that if I were to draw it?
So if pi over 6 is 30, isn't that 330 because that's negative?
Correct. Or I can just start from the x-axis and go clockwise instead of counterclockwise and make that minus pi over 6, minus 30 degrees.
Mm-hmm.
And that is the same angle as your 330 degree angle. In other words, it's coterminal to it.
Okay.
Okay. Now, to figure out what the coordinates are, well, let's look at a triangle with a 30-degree angle. Okay? And these are always right triangles, right? In other words, if I create the triangle there, that's a right triangle. And that's a unit circle, 1.
Yeah.
In other words, when we're talking about the unit circle, the hypotenuse is always 1. So the hypotenuse of these triangles is always 1.
Mm-hmm.
Now, if you remember back to geometry where you had a 30-60 triangle, and the dimensions on that triangle were 1, square root of 3, and 2.
Okay.
So what are the dimensions on that triangle? If the hypotenuse is 1, what are the other 2 dimensions? What's the side opposite the 30?
Isn't that 1/2?
And what's the side opposite the 60?
Square root of 3 over 2.
Now, reading that triangle, tell me what the cosecant of that angle is. We'll figure out the plus or minus sign secondarily. What what I have discovered about trig is that you want to figure out the absolute value first and put the sign on it second. By the sign, I mean plus or minus. I don't mean SIN. Okay?
Okay.
So, first of all, are you good with your SOHCAHTOA? Do you know what cosecant means?
I'm okay with it.
Okay, what's cosecant?
Isn't that, what is it? Opposite? No, it's not.
It's the
Gosh, I haven't done this in a
reciprocal.
while.
It's the reciprocal of what?
Isn't cosecant the reciprocal of sine?
Correct. So what's the sign here?
Isn't sine opposite over hypotenuse?
Correct. So the sine is 1/2 of 30.
Mm-hmm.
What's the reciprocal of 1/2?
It's just negative
No.
1/2.
Hold on. What's the reciprocal? Not the negative, but the reciprocal. Remember, the reciprocal is always 1 over. So if 1/2 is the sine, then the cosecant is 1 over 1/2, which is 2.
Okay.
Okay? So that's the absolute value of the cosecant of minus pi over 6. Now let's place it in the proper quadrant and put the proper plus or minus sign on it. What quadrant's this in?
Fourth. It's in the fourth.
Cosecant, what is the plus or minus sign on cosecant in the fourth quadrant?
Mm-hmm. It's negative.
Okay, so -2. And that's the process I use on every one of these problems. Is
Okay.
figure out the absolute value first, and then figure it out. You've heard of all students take calculus?
Nope.
Okay, let's talk about that for a second. I find it pretty worthwhile. Now, it sounds like you've got these memorized pretty good, but let's look at the unit circle. The A
Yeah, we had that
is
for
all
unit circle
6 trig
memorized.
functions are positive in quadrant 1. In quadrant 2, only sine and its reciprocal is positive. In quadrant 3, only tangent and its reciprocal. And in quadrant 4, only cosine. Hence the all students take calculus.
Oh, that makes sense.
Okay, now in reality, that should say sine and cosecant. And that should say tangent and cotangent. And that should say cosine and secant.
Mm-hmm.
But then it wouldn't make a nice little anagram. So they expect you to know that if sine is positive in the second, its reciprocal has to be positive. The reciprocal always has the same plus or minus sign on it as its reciprocal.
Okay.
Okay? What else?
Let's see, another one. It says, given sine of theta is 1/3, find all 6 like the trig functions.
Okay? Does it tell you where theta, what quadrant theta is in? Because you need that.
Oh, and what is it?
Probably says something like this. Theta is greater than or equal to 0 and less than
Yeah,
pi
it's
over 2.
less than 0.
Greater than 0 and less than pi over 2?
It's just less than 0. A cosine theta is
Ah,
less than 2. I didn't see the cosine.
the key part of the problem. In other words, when you give me another piece of information, that spots the quadrant. What quadrant is the cosine negative and the sine is positive.
Isn't that 2?
It's the only one. It's not true in quadrant 1, it's not true in quadrant 3, and it's not true in quadrant 4. So when they give you 2 pieces of information, that tells you what quadrant we're in. Okay? Now, the key to these problems is once you've spotted which quadrant you're in, the key is always the next step to me. Now, teachers may teach this slightly differently, but there's an easy way to do these. And the easiest way is always to draw a right triangle and label theta. So there's my right triangle, there's my theta. Now dimension 2 of those sides. In other words, this allows you to dimension 2 sides of that triangle. What are they? What's the side opposite theta?
Isn't that 1?
What's the hypotenuse?
3?
So what does that make the third side? In other words, once you have 2 sides of a right triangle, you can always calculate the third side.
Yeah, don't you do the Pythagorean's theorem? 1 squared plus x squared equals 3 squared.
You're going to find that you want to do it the faster way. You don't want to have to go back to the Pythagorean theorem every time. You want to know that a short side is the square root of the hypotenuse squared minus the other short side squared.
Right.
That's the quick way to do it.
It is? Okay.
Quicker than going all the way back to a squared plus b squared equals c squared, right?
I guess.
I've skipped the initial step, so that makes it the square root of 8, which is 2 root 2.
That's what I got.
So now I can label that side. Now you can give me all 6 trig functions. What's the cosine of theta equal to? So all you got to do is read the triangle.
The cosine?
They want all 6 trig functions.
2 square root of 2 over 3.
Now put a plus or minus sign on that.
Oh, it's in the second quadrant, so that's negative.
That's okay. That's the way I'd like to see you do it, is figure out the number first, the sign second. Now what's the tangent of theta? Number first?
So that's 1 over 2 square root of 2.
And hopefully you have a teacher that is not particularly concerned with whether you rationalize these or not.
Oh, we have to.
You're kidding, really?
No, it's annoying.
Oh, it's worse than annoying. And I tell you why. Most all trig teachers anymore don't require that. And the reason is that cotangent's just as important, right? So watch what happens. Go ahead and rationalize that. What do you get?
I got negative square root of 2 over 4.
Okay, it's...
Because I threw this sign on as well.
Okay, so I'm multiplying top and bottom by square root of 2. So that gives me square root of 2 over 4, and then I put the sign on it, second quadrant, tangent's negative.
Yeah.
Okay. Now give me the cosecant of theta.
Isn't that just 3 over 1, so 3?
Now give me secant of theta.
Negative, or it's 3 over 2 square root of 2. Let me rationalize that. It's negative.
And now rationalize that.
So it's just 3 square roots of 2 over 4, and it's a negative.
And finally, what's cotangent of theta?
Negative 2 square root of 2 over 1.
And notice what you did. You went back to that one, right?
Yeah, I went back and looked at tangent.
You didn't go to this one. You didn't go to the rationalized form, because the moment you take the reciprocal of that, now you got to re-rationalize it. And that is the reason why most trig teachers don't request that you rationalize it anymore. It's because you're working with the reciprocal as often as you're working with the tangent. So it just makes everything easier to not rationalize anything. And that really is a convention of mathematics that there's no real reason for. I don't know if you know what I'm saying, but what I'm saying is that that is a perfectly legitimate number.
Mm-hmm.
Happens to be exactly the same as this. The only difference is this has a rational denominator, this has an irrational denominator. Well, there's nothing really in mathematics that says you can't have an irrational denominator. It's just a convention that has been adopted. Okay? I think it has to do with dividing something up into a certain number of parts. And if you have an irrational number, how do you divide it up into an irrational number of parts? You can't do it. So that's where that convention came from. But when you're dealing with trig, it makes the whole subject matter flow so much easier if you don't have to rationalize numbers. In other words, that's perfectly fine as an answer.
Mm-hmm.
So far, you know these pretty good. What else? What's the next one?
Where's another one? Here's something I don't get. I don't get the whole thing of sine squared of like theta plus cosine squared theta is 1.
Mm-hmm. Here's
I don't get
why. I will explain why to you, but you don't really need to know why. Here's my unit circle, okay?
Uh-huh.
There's 1. First of all, what's the cosine of theta equal to?
I'm sorry, what?
There's x
What'd
and
you say?
y, right?
Yeah.
Here, look at my unit circle. What's the cosine of theta? It's equal to x over 1, right?
So it's just x.
Right. Now look at this right triangle. X squared plus y squared equals 1, right?
Uh-huh.
That's cosine squared plus sine squared equals 1. In other words, sine of theta is y. So this point right there, very important to understand that that point has coordinates cosine theta, comma, sine theta. As long as you're on the unit circle, no matter where you're at, you're over here, and that's your angle, theta. That point is cosine theta, comma, sine theta. In other words, the x-coordinate is cosine theta, the y-coordinate is sine theta. And that's why cosine theta plus sine theta, cosine squared theta plus sine squared theta is always equal to 1.
Okay.
Okay? It's really something you don't really need to know why. It's just something you need to memorize. There are 3 Pythagorean identities. That's the most important one. Well, not really the most important one. That's just the first one they teach you. So you always have to memorize that. And this is true no matter what theta is. Theta could be 10 degrees, theta could be 30 degrees, theta could be 270 degrees. This is always true. Second one that at some point they make you memorize is this one. That's always true. So you have to memorize 1 and 2. And then there's a third one that they want you to know, but you can always figure it out from the second one. The third one is the cofunctions of the second one. And by cofunctions, I mean I stick a co in front of the word tan, and I stick a co in front of the word secant. So it's cotangent squared of theta plus 1 equals cosecant squared of theta. So you don't really have to memorize number 3, you just have to know that number 3 is the cofunctions of number 2.
Okay.
Okay? And that's the best way to memorize. And you do need to know all 3 of those. Those are part of the 11. In other words, there are, let's talk about them, because it sounds like you probably have most of them memorized anyway. There are 6 reciprocals, right?
Mm-hmm.
And you know all 6 of them?
For what?
What's the reciprocal of sine?
Oh, that's cosine.
No.
Or no.
Reciprocal of
Gosh, cosecant.
Okay, the reciprocal of cosine.
Secant.
And the reciprocal of tangent.
Cotangent.
Which makes the reciprocal of secant what?
What is that? Cosine?
Right. So there's your 6. In other words,
Okay.
the 3 that you've memorized and their partners.
Mm-hmm.
So that's 6 reciprocal relationships. You have these 3, these are called Pythagorean identities. And then you have 2 more. And that is tangent of theta equals sine over cosine. And cotangent of theta equals what?
Isn't that...
Well, it's the reciprocal of tangent.
Yeah.
So what would it be?
So it's cosecant over...
It's the reciprocal of tangent, so just flip that.
Oh, so cotangent?
Which makes it cosine over sine.
Yeah.
So you don't have to memorize this one either. You just have to memorize that one. So in terms of memorizing these 11 key trig identities that, trust me, you got to memorize at some point, you really only have to memorize 3. They're 3 reciprocal, these first 2 Pythagorean, and really only 1 quotient. These last 2 are called the quotient identities. So if you memorize those 6, you can always figure out the other 5. And that's really the way to think about it. Don't think about it as having to memorize 11 things. Memorize always as few things as you possibly have to. All right. So we've covered all 11 identities. What do you got next on your problem?
So given sine of theta equals 1 over the square root of 5, and cosine of theta is 2 over the square root of 5, it wants us to find the 6 trig functions again.
Okay. Notice he didn't rationalize them.
Mm-hmm.
What quadrant are we in? That's the first step.
Isn't that the first quadrant?
Has to be. It's the only place both sine and cosine are both positive. What's the next step?
Draw the triangle.
What's the next step? Actually, it's draw the triangle and Label theta. Because theta could be up there, theta could be that one. Theta is one of those two. We don't know which yet. So we've got to label it. And I could label it up here just as easily as down here. My practice is usually to label that one theta. Now what?
Put the numbers on the correct sides.
Okay,
So
dimension the whole triangle for me.
yeah,
What's opposite theta? Always start there.
1.
What's next?
The hypotenuse, which is the square root of 5.
And what's that make the third side?
2.
Correct. Because they gave it to us, but they didn't need to give us this. We could have figured it out, right?
Mm-hmm.
In other words, all they needed to say was that theta is in the first quadrant. They didn't need to give us any information other than theta is in quadrant 1. Then we would have been able to figure out that that third side was 2, and that we're in quadrant 1. So all 6 trig functions, well, they gave us this one, so we don't need to figure it out. And notice why it was easier for him to give it to you with an irrational denominator. Had he rationalized it, the whole problem would have been a little harder. What's tangent of theta?
That's 1 over square root of 5.
No. So could TOA. TOA is opposite over adjacent.
Oh, over adjacent. So it's over 2.
Okay. And what is the cosecant of theta?
Isn't that just square root of 5 over 1?
Correct. Again, it's easier because he gave it to us not rationalized. We don't have to worry about rationalizing anything. What's the secant of theta?
Square root of 5 over 2.
And finally, what's the cotangent of theta?
2 over 1, or just 2.
That's how you do these problems. This is probably the quintessential problem in trig. If they were going to give you a trig test and they could only ask you one question, it would probably be something along the order of this. Only they would make it a little harder and they would merely tell you the quadrant. They wouldn't actually tell you what the cosine of theta is. They don't need to give you that information. That does tell you that it is in quadrant 1, but they could have just as easily said theta is in quadrant 1. Okay, then you would have had to supply the 2 using the Pythagorean theorem. All right, what else you got?
All right, here's the next one. So it's if sine of theta is 0.3, find sine of theta plus sine, and then in parentheses, theta plus 2 pi, and then at the end of the parentheses, plus sine of, and then parentheses, theta plus 4 pi.
Like this?
And then, yeah, and then the next one's just sine of theta plus 4 pi. Yep.
Okay. The sine of theta is 0.3. What's the sine of theta plus 2 pi?
Just sine of theta plus 2 pi.
What number is that? Remember, we always take trig functions of angles to get numbers, and we take inverse trig functions of numbers to get angles. So there's a number that goes with sine of theta plus 2 pi.
Sine of theta plus 2 pi.
Let me do this.
So that's twice.
The sine of theta is 0.3. So I'm going to say that's 0.3 over 1, correct?
Yeah.
Now the sine of theta plus 2 pi, well, that means I go around once entirely, and then I go back to there.
0.3.
Okay? Now the sine of theta plus 4 pi is I go around twice and back to there.
Mm-hmm.
So what's the sine of theta plus 2 pi?
Just 0.3.
What's the sine of theta plus 4 pi?
0.3. So
All three of them
0.9. 0.9. Yeah.
0.9. In other words, these are called coterminal angles. I don't know if you've come across that term yet. Coterminal angles are any angle that is a multiple of 2 pi from theta, either
Mm-hmm.
forwards or backwards. So the sine of theta minus 2 pi would also be 0.3. Or the sine of theta minus 4 pi would also be 0.3. The sine, all trig functions of an angle and all angles that are coterminal to that angle are the same. What I mean by that is if the sine of 30 degrees is 1/2, then the sine of 390 degrees is 1/2, and the sine of 750 degrees is 1/2, so forth and so on.
So it just doesn't matter how many times it goes around as long as it lands where it started?
Exactly. And in fact, the sine of minus 330 degrees is also 1/2. In other words, whether I add 360 or subtract 360 does not matter. They're both coterminal to 30, which means they have the same trig number. You put it into your calculator, whether you put in 30 or 390, you'll get 1/2, or 750, you'll get 1/2, so forth and so on. That's true for all trig functions, not just sine. Okay, what else we got?
Let's see. Okay.
So have you dealt with inverse trig functions yet? In other words, when I say inverse trig function, I mean the inverse trig function of
No.
the inverse sine of 1/2 is 30 degrees. Notice that if the sine of 30 degrees is 1/2, by definition, the inverse sine of 1/2 is 30 degrees. Notice we take inverse trig functions of fractions to get angles. We take trig functions of angles to get fractions.
Okay.
These are if and only if. If this is true, then this is true. Or if this is true, this has to be true.
Mm-hmm.
Okay. What else? Let's cover what you've covered rather than getting ahead of it. Although it sounds like you're staying on top of it pretty good.
Mm-hmm.
It doesn't
I'm
sound
out of problems.
like you're behind at all, especially if you haven't gotten to inverse trig functions yet. That's coming real soon.
Yeah, we have our test Monday.
Okay, it'll come right after your test. In other words,
Probably.
test, the next subject matter you'll talk about is going to be inverse trig function. So let's focus on what's going to be on your test. But
So So we have the unit circle. We have to memorize that, which I'm pretty sure I'm mostly done with.
Okay, let me test you. Give me the x and y coordinate.
So that's for 30 degrees.
Sorry.
So isn't that what?
Remember, the first one is the
3
cosine.
square root of 3 over 2,
Uh-huh.
and then 1/2.
Uh-huh.
I always get that mixed up with the other.
That's the cosine of 30, and that's the sine of 30.
Mm-hmm.
Okay? About 45.
Oh, that one's just square root of 2 over 2, and then square root of 2 over 2.
About 60.
That's the opposite for the 31. So that's the 1 over 2, and then the square root of 3 over 2. And 90 is just 0, 1.
Notice that is the coordinates of that point.
Mm-hmm.
0, 1. And that's one of the things that makes it a little bit easier to memorize. These are called quadrangles. Quadrangles are multiples of 90. So what is the 180 degrees?
Negative 1, 0.
Which means, what's the cosine of 180?
Just negative 1, 0.
Or just negative 1, just the cosine.
Oh, yeah.
The sine of 180 is 0.
Mm-hmm.
So what's the sine of 270?
Isn't that just y? So that's just negative 1.
Mm-hmm. What is the cosine of 270?
0.
Okay. What is the sine of minus 30? You've dealt with negative angles?
Yeah.
Okay. What's the
Isn't that
sine of
just
minus 30?
negative 1/2?
Good.
Because that's just 330.
What's the cosine of negative 30?
3 pi over 2. Or not 3 pi, square root of 3 over 2.
And notice that it's positive
Mm-hmm.
because it's all students take calculus. Cosine is positive in the fourth quadrant. And we're in the fourth quadrant when we talk about minus 30. What is the sine of 150 degrees?
It's 1/2.
Good. Cosine of 150?
Square root of 3 over 2. Oh, it's negative. So negative square root of 3 over 2.
I like the way you did it. It's square root of 3 over 2, only negative. Because that's following that same pattern where you figure out the number first and put the sign on it second. Maybe I like that because that's just the way I've always done it. I don't suppose there's anything magical about that. In other words, you can put the plus or minus sign on it first if you want, and then figure out the number. I just always found it to be a little easier the other way.
Oh no, it seems like it's 50-50 for me.
Is it? Okay. Okay, so you know your unit circle good. What else do you need to know? You know your unit circle. You know how to do it if they give you one trig function, how to get the other 6, as long as they tell you give you enough information to allow you to put it in the correct quadrant.
Mm-hmm.
So let me give you one. If the sine of theta is 2 over 7, and the tangent of theta is less than 0, give me all 6 trig functions of theta.
Okay, let me just write this down real quick. Okay, so the sine is 2 over 7
Okay.
because its tangent of theta is less than 0.
Okay.
Let's see.
What's the next thing you want to do, given those two pieces?
Find the quadrant, right?
Okay. What quadrant's it in?
It's less than 0, so it's in the second or fourth. And then because sine is positive, it means it's in the second.
Good. Now the next step.
Now we have to get the rest of them.
Nah,
So we draw the
triangle.
yeah.
I consider that a key step. That frequently is the first step in my book. And I'll figure out the quadrant later. What else besides just draw a triangle?
Label it.
Label theta. In other words, I could put theta up there, which is perfectly fine. But you got to know where theta is in order to be able to label this triangle. I'm going to draw theta up there. Label the triangle for me. Dimension. What's opposite theta?
That's 2.
What else do you know?
The hypotenuse is 7.
And what's the third side?
So it's x squared is 45.
This is where it really helps to do the technique where when you're solving for the short side, it's the square root of the hypotenuse squared minus the other short side squared. It's helpful to go directly to that, rather than having to go back to a squared plus b squared equals c squared. That requires you to do a lot of algebra to get it into the spot that you need to get it into.
I got
And
3 squared.
since you do this so much, it's helpful to be able to immediately say that the other short side, and we can call it A or B, is, all of them start out with the square root. In other words, I want to go directly to that. If I'm solving for the hypotenuse, it's the square root of a squared plus b squared. If I'm solving for the other short side, it's the square root of the hypotenuse squared minus the other short side squared. In other words, if you can go directly to these three when you're solving that third side, it saves you a lot of time. You don't always want to have to go back to the original. It's one of the few times where I really recommend people memorize the second one. Even though normally I would say always just memorize the Pythagorean theorem and you can always figure out these three using algebra. But in this case, I don't believe that's what's most efficient. I believe it's most efficient to memorize these three. Only because you have to do it 100 times at least. Maybe 200 over the course of your math career. And because you have to do it so frequently, it doesn't make sense to have to go back to the original equation every time. Okay? So that's our triangle. Tell me what the cosecant of theta is.
3 square root of 5 over 7.
Where's theta? Theta's up here.
Yeah.
So, you were close. You gave me the cosine of theta.
Oh, did you say cosecant?
Cosecant, yeah.
Oh, okay. That's 7 over 2.
Correct.
I thought you said cosine, sorry.
It's okay. What's the secant of theta?
Isn't that 7 over 3 square root of 5?
Negative. Remember, we're in the second quadrant.
Oh, yeah, I forgot about that.
There's always going to be two main steps here. There's going to be drawing the triangle, dimensioning all three sides, And there's always going to be figuring out which quadrant you're in. Once you're looking at the triangle and you know which angle is theta, and you know which quadrant you're in, now it's a piece of cake to figure out all 6 trig functions, right?
Mm-hmm.
It's these 2 things that are the tough part, right there. Once you get those 2, the rest of it's easy. Okay? Feel like you're going to do pretty good on this test. Just be very, very specific that you get the quadrant correct and the plus or minus sign correct.
Mm-hmm.
And I guess rationalize them. Kind of funny, actually. I started tutoring about 9 years ago. And 9 years ago, I didn't find any teachers. Oh, every teacher I came across forced you to rationalize it. And then about 5 years ago, I started coming across every now and then 1 or 2 teachers that said, no, don't rationalize them. And now I would say it's about 80%. About 80% of the teachers that teach trig do not suggest that you rationalize it. They leave it in unrationalized format, merely because it's trig. And you're dealing
It's still a number that works.
You're dealing with sine as much as cosecant. So, you know, one needs rationalized, the other doesn't. And in fact, if you rationalize one and you erase the original answer, now you got to rationalize it twice to figure out cosecant. So it's particularly onerous to have to rationalize in trig. That's why so many teachers don't make you do it anymore. What else? Got any other type problems that we haven't looked at? Every type that we've looked at so far, you're pretty good at.
No, that's pretty much it.
Now, let me make sure.
Other than, I guess, the radians to degrees, or like where they are on the unit circle. Because we have to memorize that too.
Well, just remember the conversion factor. How do you convert radians? How do you convert degrees to radians?
It just times pi over 180.
Notice that when you're converting degrees to radians, it has to be pi over 180, not 180 over pi. Because
put the pi on the bottom.
The degrees cancel, and you're left with radians, which is what you want. And if you're going from radians to degrees, then it must be 180 over pi, because the radians go with the pi, and the radians need to cancel. And you need to figure out the answer needs to be in degrees. So that's how you can convert from radians to degrees. I don't see that giving you any problems. What was the other thing you said right before that? Oh, I know what I was going to do. I presume you've seen this. In other words, quadrant 1, 2, 3, 4. This is theta minus 180, and this is 360 minus theta. Or you can write these as pi minus theta if you're dealing in radians, or theta minus pi, and this one would be 2 pi minus theta. So if I said to you, what is the sine of 225? How are you going to figure that out without a calculator?
So sine of 225 is that what's opposite over adjacent, and it's negative square root of 2 over negative square, and then the other one is negative square root of 2 over 2.
So you actually are drawing upon your memory of the unit circle when you do that?
Yeah.
As opposed to the way I do it, which is I always try to figure out what the equivalent first quadrant angle is. And I do it by using one of these formulas. In other words, that's in the third quadrant, right?
Yeah.
So 225 minus 180. I use this one right here, which means I'm basically looking at the same numerical value as the sine of 45 degrees, which is square root of 2 over 2, but it's third quadrant, so it's negative square root of 2 over 2. That's the way I do every problem, is I take whatever angle they give me, and I convert it to the first quadrant angle. And I use it, I convert it based on these.
Okay.
And as long as you've got the unit circle, you're one of the few people I've ever known that's actually memorized the unit circle the way you've done it. In other words, you've actually memorized all 16 spots on the unit circle, right?
Kind of, yeah.
Well, there's exactly 16 of them. There's 1, there's 2, there's 3, there's 4, and there's 4.
Yeah, I guess there is.
There's 4 in each one. So you've memorized all 16 spokes of that wheel, which is wonderful. I don't have it memorized, to be honest with you. What I have memorized is the first quadrant. I know.
Well, I just memorized the first quadrant. I'll just throw a negative in front of it.
I'm sorry, what?
I just mainly have the first quadrant memorized, and I'll just throw a negative in front of it.
Which sign to put in front of it? Yeah.
Yeah.
Okay. Well, I do the same thing, only I use these formulas to figure out what the first quadrant angle is. In other words, the way I converted sine of 225 is by using theta minus 180. That tells me that it's the same as the sine of 45 degrees.
Mm-hmm.
Not the same, but it's the same absolute number. And then you put the plus or minus sign on it, and you get your answer. So we basically kind of do it the same way. But in order to do it that way, in other words, in order to convert a second, third, fourth, fifth, sixth, seventh, eighth to a first quadrant angle, you have to know how to do it. In other words, what is the sine of 300?
So that's 1/2 and then negative 3, square root of 3 over 2. So that's, what is that? Draw that.
Well, here's the way I would write it.
1/2 square root of 3.
We're getting 1/2. In other words, here's the way I would write it. I'm saying the sine of 300 is the same as 360 minus 300. So it's the same as 60. Sine of 60 is root 3 over 2. 300's in the fourth quadrant. Sine is negative. That's the way I do it every time. In other words, this is a critical step for me. I'm not sure that it's necessarily going to be necessary for you, because you've got the whole unit circle memorized pretty good. But me, I really only have the first quadrant memorized. That's all I need to memorize. I can take any angle you want to give me and convert it to a proper first quadrant angle. And then I know what the sine of 60 is. And I know 300's in the fourth quadrant, so I know what plus or minus sign to attach. Let me give you a couple of those. Tangent of 135.
So it's square root of 2 over 2, or that's negative, and then is that over square root of 2 over 2?
It's not square root of 2 over 2.
Tan is just the...
First of all, what is the equivalent first quadrant angle that I'm talking about?
45.
Okay. Now, if you forget these, the first quadrant ones, you can always get them from these two special triangles that you've been studying for 3 years. The 45-45 and the 30-60. Notice the 30-60. Whoops. 1, square root of 3, 2. That's 1, 1, square root of 2. And now looking at that one, tell me what the tangent of 45 is.
Square root of 2. Wait, no. That's the... Oops, just dropped my phone.
A little trouble with tangent. It's the only one that gives you any problem at all. Tangent is opposite over adjacent.
So it's just 1 over 1?
Uh-huh.
So just 1.
Toa. Toa is opposite over adjacent.
I guess it just trips me up because it's the only one without a hypotenuse.
Yeah, it is. Tangent and cotangent. It is the only one without the hypotenuse. So it's 1, but now what is its plus or minus sign for the tangent of 135 degrees?
Isn't it negative?
Because it's in second quadrant.
Mm-hmm.
Okay. I can't think of anything else to ask you. Can you find any other problems on your review sheet that we haven't talked about yet?
I haven't.
Yeah, I think you got it pretty good. Just to be clear, you don't really have to memorize the first quadrant angles. If you know these two triangles, you can figure out the unit circle. It's as simple as that. You don't need to know anything else. You don't need to memorize the unit circles. All you need to know is these two triangles and their dimensions. And you should have actually learned these prior to geometry, back to Algebra 1. You should have been dealing with both of these two triangles. They're so common in geometry and trig. Notice, sine of 30 is 1/2. Cosine of 30, square root of 3 over 2. Tangent of 45 is 1. What's it? Sine of 45 is 1 over root 2. Now, sometimes the second one, they will teach it a little differently. They'll make this root 2, and that 2. Well, that's the same 45-45 triangle. It's just root 2 bigger. In other words, the scale factor is root 2 between these two. The advantage of teaching students this one is that the sine of 45 degrees comes ready rationalized. Notice the sine of 45 degrees is square root of 2 over 2 for this one, whereas for this one it's 1 over root 2. So if your teacher is going to make you rationalize these, my guess is you probably got taught that one right there as your 45-45 triangle to memorize.
We got taught. I remember back in geometry and algebra 1, we used the 1-1 and then square root of 2.
This is the one I like. It's the reason is the following. I call these my unit special triangles, and I get the word unit from the fact that opposite the smallest angle is 1 in both cases. Opposite the smallest angle is 1. So that's why I like using this one, is because then it fits the definition of my unit triangle. And much like a unit circle always has a hypotenuse of 1, then my two unit triangles always have the opposite side of the smallest angle as 1. And then that gives you all 6 trig functions for all of your angles in the first quadrant.
Mm-hmm.
The only thing these do not give you are your quadrangles. In other words, this one doesn't tell you what the sine of 0 is or the sine of 90 degrees. You can use a little bit of out-of-the-box thinking to figure it out, but you've got those memorized anyway. So we don't need to go there. But Pam, you're going to do good on that test. I can feel it. Good luck. I will talk to you next time.
Thank you.
Bye-bye.